So this video is going to be about number systems, how to convert one number system into another. For example, let's say if we have a decimal number 765 and we wish to convert that to a hexadecimal number. So you can use this function. Decimal to, well, first you have to write equal decimal to hexadecimal and then type in the number 765. And so we get 2FD. Now, it's important to understand that in the hexadecimal system, A is equal to 10, B is equal to 11, C is equal to 12, D is 13, E is 14, and F is 15. Now, to check your answer, here's what you can do. So starting with the first one, D correlates to 13. So we need to multiply 13 by 16 to the 0 power, and then add that to F, where F is 15, so plus 15 times 16 to the first power, and then 2 times 16 to the second power. And that will give us our original number, which we could see here, 765. Another way in which you can get that answer is you can use the reverse function. So that's hexadecimal rather, 2 decimal. So you can type in equals hex 2 decimal and then in quotations 2 FD. And so that's how you can go back from hexadecimal to decimal using that feature. Now let's talk about converting from binary to decimal. And let's start with a simple example. So we can write equal binary to decimal, and let's type in the number, let me see, let's try 11. Actually, I want to go from decimal to binary first. So we get the number 1011. Now to convert that into or back into a decimal number, you can write, starting with the right digit, 1 times 2 raised to the 0 power, and then plus 1 times 2 raised to the first power, plus 0 times 2 raised to the second power, plus 1 times 2 raised to the third power. And I forgot to put the equal sign. And so as you can see, it gives me the original decimal value, which is 11. Or you could use a reverse function, equal binary to decimal, and then type in 11. Actually, not 11, 1011. And that'll give you 11. So now you know how to go from decimal to binary and binary to decimal. So let's try some other examples. Let's say if we want to go from decimal to binary, and we have a large number like 120. So that's the binary number that corresponds to 120. And going backwards, so binary to decimal, 111100, and that will give us 120. Now sometimes you might have issues if you're using large numbers. For example, going from decimal to binary, let's use 765. Notice that we don't get a result here. One way around this situation is to use, instead of decimal to binary, we can use the base function. So we type in equals base and then 765 comma 2, because we want to convert it to the binary system, which is a base 2 system. This will give us the binary number, 10 with a lot of ones and then 01. Now to go backwards, you can type in equal decimal and then type in the binary number 1011111101, and then that should be it. I got to put comma 2. Okay, so that gives me the original number 765. So that's another way in which you can convert from binary to decimal and decimal to binary if the other feature is not working. Now let's talk about some other things that we can do, such as converting a decimal number into the octal system. So let's say we want to convert the number 536. And so 536 as a decimal is 1030 in the octal system. So to confirm it, we're going to multiply the first number on the right, 0, by 8 to the 0 power, and then the second number, 3, by 8 to the first power, and then plus the third number, 0, times 8 to the second power, plus the last number times 8 to the third power. And once again, I forgot the equal sign. And so as you can see, we get our original number 536. Now we can also confirm it by using this function, octal to decimal, and let's type in 1030. And so we can also get 536 that way. So now you know how to convert from the octal system to the decimal system, and from the decimal system into the octal system. Now there's some other things we can do. So let's say if we want to go from binary to hexadecimal. Let's say we have the binary number 10110011. And so that's 167 in the hexadecimal system. To convert back, just use hex to binary, and then let's type in 167. And so that gives us the original binary number. Something else we could do is convert from octal to hexadecimal. And so let's say we have the number 3765. So that's 7F5 in the hexadecimal system. So to go back from hex to octal, since we have a letter, let's use the quotations, and then 7F5. And so we get the original octal number. And so now you know how to interconvert from one number system into another. So if you want to go from, let's say, binary to octal, you can do so as well. So let's use the number 11101001110. And so we get, that doesn't seem right. Let's use a smaller number. 110101. Okay, that seems reasonable. And then equal octal to binary 65. So we get the same answer. So sometimes you'll see that if you have too many numbers, the Excel software may not produce the right result. So you may need to find another way in which you can get the answer. But let me try something similar. So binary to octal, but I'm not going to use 10 digits, just maybe 9. And so that worked. I guess when I used 10 digits, something happened. So going back from binary to octal, octal to binary. So that worked. Now, let's say if you need to convert a large binary number into an octal number, but for some reason, the Excel software is not allowing you to do so. What you could do is use this function. It was decimal, and then parentheses. You can type in the large binary number. So let's make sure we use more than 10 digits. And then comma 2. So we can convert the large binary number into a decimal number. And then once we have that, we can go from decimal to octal. And then 3533. And so our answer is 6715. Now, to confirm it, here's what we can do. So let me use this drawn feature. So we have the octal number 6715. So first, convert 5 into a binary number, which is 101. So keep in mind, this is 1, 2, 4. 4 plus 1 is 5. Next, convert this into a 3-digit binary number, which is going to be 001. And then convert 7 into a binary number, which is 111. And then 6 is going to be 110. This is 4 plus 2, which is 6. 4 plus 2 plus 1, that gives us 7. And so that's how you can convert from octal to binary. So this is our answer. And if we highlight this cell, you could see we have the number 110, 111, 001, 101. So we know the answer is correct. And so sometimes you may need to find another way to convert from binary to octal. If one method is not working, try another method.